Alright, so continuing on with our 6 weeks test exam review. Number 13, when a projectile is in free fall, what are all of the forces acting on it if we can ignore air resistance? Well, the definition of free fall is an object is in free fall when the only force acting on it is gravity. So if we're ignoring air resistance, then the force of gravity downward is the only force acting on an object in free fall. Number 14 says draw a free body force diagram for each of the boxes in questions 8 through 10. So, in question 8, you're going to have the force of gravity acting straight down, and since you're pushing it across the floor, there's going to be a normal force, Fn. Those are equal and opposite. And if you're pushing with a constant force, this is the force that you apply, or I'm going to call it F1. So this would be what it would look like in question 8. Question 9 says, if you suddenly stop pushing the box, what does it do? Well, if you stop pushing the box, and we're ignoring friction, you still have the force of gravity and the normal force, and they are still equal to each other. The object is still moving this direction with a constant velocity, but those forces cancel out, so the net force is still 0. So that's the situation for question 9. And question 10 says, if you do not ignore friction, what would your answer to number 9 be? Well, if we do not ignore friction, we still have the normal force, we still have the force of gravity, just this time the object's moving this direction, you have a force of friction slowing it down. So those would be the free body force diagrams of the situations from questions 8, 9, and 10. Number 15. Johnny Bravo figured out how to travel to distant worlds in a spaceship. I'm going to move this as I read. You have the paper in front of you. He found himself on a random planet with a mass, so the mass of the planet is 2.5 times 10 to the 12th kilograms, and a radius, so the radius is 5.8 times 10 to the 7th meters. What is the acceleration due to gravity on this planet? I want little g. Okay. Now, the question also says, see the example problem on my website, because I already worked one of these out as one of the other example problems, but I'll finish working it here. This is the mass of the planet. So I'm going to say the mass of me. And I'm going to make it simple on myself and just say 1 kilogram. It really doesn't matter, and you'll see why in a minute. I know that big G equals 6.67 times 10 to the negative 11th newtons times meters squared per kilogram squared. Now, the weight of an object, Fg, is given to you by the mass times little g. But Fg is the force of gravity, so the force of gravity between two objects is also big G times m1 times m2 divided by d squared. Since both of these are Fg, they're equal to each other. So mg equals big G m1 m2 over d squared. Now if we say that the mass of the planet is m1 and the mass of me is m2, my weight on that planet is my mass times the acceleration on that planet, so that's m2. So if I'm solving for g, I simply divide both sides by m2, and you'll see that m2 cancels out. So little g is big G times the mass of the planet divided by the distance between two objects. Well, if I'm on the planet, the distance from me in the center of that planet is the radius. And since distance is squared, it's the radius squared. So if you plug these numbers into this equation, you will get the right answer. I don't have a calculator with me at this moment, so I'm not going to solve that for you. You can do that on your own. Number 16, So the force of gravitational attraction between ball A and ball B is 5.84 times 10 to the negative 10th newtons. If the two balls are 20 meters apart and the mass of ball B is 70 kilograms, what is the mass of ball A? Well, same equation. F equals big G times m1 times m2 divided by d squared. And I know that the force between them is 5.84 times 10 to the negative 10th newtons, and the distance is 20.0 meters, and I know the mass of one ball is 70.0 kilograms. The mass of the other ball is what I'm looking for, and I know that big G is 6.67 times 10 to the negative 11th newtons times meters squared per kilogram squared. So, plugging into this equation, I'm going to solve for m2 first. So to solve for m2, I need to multiply both sides by d squared so that my d squareds cancel. And then I'm going to divide both sides by gm1. So my g's and my m1's cancel. So that means m2 is d squared times f divided by big G times m1. So I have all of this information here. It's all right here. Simply plug it in and solve to get your answer. Again, I'm not going to solve it for you. You can do that on your own. Number 17 says a 15 kilogram car travels in a circle of radius 256 meters at a constant speed. If the force of friction between the car's tires and the road is 35,700, what is the speed of the car? Okay, so we have a car traveling in a circle, and it tells us the mass of the car is 1,500 kilograms, and the radius of the circle is 256 meters, so that's my radius. The force of friction between so we know the force is 35,700 newtons, and it wants to know the velocity. Alright, well, in order to find the velocity, we have to know the acceleration, because he's going in a circle. We know he's accelerating, and we know he has a centrifugal acceleration. If we know the centrifugal acceleration, we can find the tangential velocity. Alright, so F equals m times a. Well, so I have my mass, I have my force, so my acceleration is my force divided by my mass. And if I know my force, I know my acceleration, and I know that the acceleration here, this force, is caused by friction, which is the centripetal force in this case, because it's the only thing there. That means my centripetal acceleration is v squared over r. So I multiply both sides by r, so they cancel out, and then I have to take the square root of that to get my v. So v equals the square root of my centripetal acceleration times my radius. Now, since v is what I'm looking for, and AC is this right here, I'm simply going to plug this in to that equation. It gives me v equals the square root of f over m times r. You plug your numbers in, plug these numbers into this equation, solve, will give you the speed. Okay? And number 18. A driver speeds along at 300 meters per second when he sees flashing lights of a police car. He slams on the brakes, comes to a stop in 3.9 seconds. If the mass of the driver car is 1,250 kilograms, what was the force of friction that caused the car to stop? So, it gives me the initial velocity is 300 meters per second, The final velocity is 0 because he comes to a stop. Time is 3.9 seconds. His mass is 1,250 kilograms, and it wants to know the force. Well, in order to find the force, I have to know the acceleration because F equals m times a. So I have to know the acceleration. So, to find the acceleration is Vf minus Vi divided by t, which I have all of that information. My Vf is 0, so my a equals a negative Vi over t. And if I plug this in for my acceleration here, then my force is my mass times a negative Vi over t. Plug your numbers into this equation, and that will give you the answer. Thank you.